purpose of this video is to give you some help with the chemical reaction types and their equations lab write-up. So what I've done here is I've put in some fake data. This is data that's not going to be what you got in the lab, but it's there to help you so you can figure out what to do with your data. So let's take a look at the first one. This is for the one with the magnesium. And the idea was that you were supposed to weigh the crucible empty first. And let's say it was 70.00 grams. Again, it wasn't 70.00 grams in your case. And then you weighed it again after you add the magnesium. It'd be 75.000 grams. It should be clear to you that the mass of magnesium in the crucible would be the difference between those two values. It'd be 75.000 minus 70.000. And the mass would be 5.000 grams of magnesium in the crucible. The next thing it asks you to do is quote the mass of the unknown product in crucible after heating it. So it should be clear to you that what's happened is that it was 75.000 grams before it was heated, and then after it was heated it's now 78.291 grams. So the mass has clearly gone up. So what you need to do is figure out the change in mass. And I think that should be fairly clear for you to be able to do as well. So this is the thing you'll put in here. That's why I put a question mark. I think you can figure that one out yourself. So where did the extra mass come from? Well, it says that the final product is magnesium oxide. The clue there is in the oxide. See if you can figure out what else the magnesium combined with in order to get that increase in mass that we just talked about. Alright, assuming all the magnesium reacted in reaction, what's the total mass of product form? Again, I think you should be able to figure that out as well. So in the next part, this is where you do the decomposition reaction with that copper carbonate hydrate hydroxide compound. And again, I'm giving you some fake data here. If the crucible and contents before heating were 78.786 grams, and then you weighed it again after it was heated, you can see it's 78.000 grams, and you can see that the difference there would be 0.786 grams. So that would be a change in mass. In the case of a decomposition reaction, instead of going up, the mass goes down, and that makes sense because whatever you're putting in the crucible is not gaining mass, it's decreasing in mass because it's decomposing. It's turning into things that are disappearing from the reaction and thus leading to a loss in mass. The color change will tell you what product was formed, and if you'll remember in the reaction you were asked to click on the crucible or double click on the crucible, and that revealed its contents, and you were able to tell the color change that was occurring. So using my fake data, or continuing with my fake data here, it's asking here what the number of moles of solid product formed were, and that would be the difference again between the full crucible, the crucible before heating and the crucible after heating. That would be the mass of product that's left in there. If you want to find the number of moles, we use this kind of equation here. They tell you that the molecular mass or the molar mass of the product is 79.545 grams. In order to get moles, what we do is we times the grams of product by 1 mole of product over the number of grams in 1 mole. So whenever you've got one thing over one thing like this, it means those two things are related to each other or equal to each other. As it says here, it's this many grams per 1 mole is how you can read that, or this many grams for every 1 mole. So in order to get moles, this is how we can figure out that equation. You'll do something similar with yours, but obviously with your data. The next thing it's asking for is the grams of water that were released as water vapor, and they give you a couple of hints here. They tell you that there's 1 mole of water for every mole of solid product produced. So what we can do is we can figure out the number of moles of product using the same kind of equation as I just showed you up here. Except they give you the grams of product here as being 3.327, so you'll use the same thing there as they ask you to use. That'll give you certain moles of product. The other clue they give you is you get 1 mole of water for each mole of product. So as you can see, that'll give you the moles of water. As you're probably going to surmise, those are going to be the same. Well, it makes sense. I mean, it says 1 mole of product gives so 1 mole of this reactant gives 1 mole of water. So I think it's probably obvious that these two things are going to be the same. After that, you've got the moles of water and you want to figure out the grams of water. Now, in order to do this, we use again the molar mass of water, which they haven't given you here, but I'm telling you is 18.0 grams of H2O. And the way we can do that, or get the 18.02 grams, is by adding the molar masses up, or the atomic masses up, off the periodic table. O is 16 and hydrogen is 1.01, and there's 2 of those, so that adds up to 18.02 grams of water. In order to figure out the moles of water, we take this molar mass and over 1 mole of water. Again, 18.0 grams of H2O is 1 mole of water, so that gives us grams of H2O over here. The next part is the single displacement. That's where you add the zinc to the hydrochloric acid, and it's asking for the observations, and you can learn something about these observations here. The next portion is the double displacement. That's when you had the sodium hydroxide and nickel chloride. So quote what happened here when they were combined. Now, in order to do this next part, I'm going to give you another example. So what I'm going to do is I'm going to draw some pictures over here on this side, and I'm going to give you some clues about how to figure out the ions present in NiCl2. Now I'm going to use a different example. I'm going to use AlCl3. So if I had AlCl3 aqueous and I wanted to know what ions were present, it's a fairly simple process. Here's what I do. I take the aluminum, and next to it I write 3 chlorines. How do I know that? Well, there's 1 aluminum, there's 3 chlorines. Now what I know is that the charge on chlorine off the periodic table is 1 minus. Now the way we know that is we can look at the periodic table. It's in group 7. It needs 1 electron in order to get its octet, so we know that each of those is going to have a negative charge. If each of those has a negative charge, the total negative charge is 3 minus. In order for this to be a neutral compound, the charge on the aluminum would have to match, so I'd know that the charge on aluminum is 3 plus. You can use similar logic to figure out what happens with NiCl2. Draw a picture, figure out how many chlorines you're dealing with. The charge will still be 1 minus, just like it was in this example, and then you'll be able to figure out the charge on the nickel as well. I'll do the sodium hydroxide for you. When sodium hydroxide breaks apart, it becomes Na and OH. The charge on OH is -1, and the charge on Na is 1 plus. So that's what that splits into, is Na plus and OH minus. In the conclusion section, it asks you to do some balancing. I've helped you out a lot here by showing you what the reactants and products are for a lot of what's going on. So in the first one with the magnesium, it gains mass because oxygen is added and it becomes magnesium oxide. And what I've done here is I've given you the reaction, but I haven't balanced it. Now what I want to point out here is I've got these lines in front of each of these, and the lines here are supposed to have numbers on them. Now just remember, if you put a number here, let's say a 3 for example, you put a 3 here, that means that in this compound you'd have 3 magnesiums and 3 oxygens. So I want you to be able to put numbers in front of here so that everything balances. That means that we need the same elements on both sides of the reaction. I'm hoping you can figure that out. In the second one, that's the copper carbonate hydroxide hydrate that we dealt with. That was that green compound. And then it turned into something that was the mystery compound we figured out earlier. And then it gives water and CO2. Now I know in the other question it said it gives 1 mole of water. I completely disagree with that. It's not 1 mole of water. it gives a certain number of other moles of water. So there's going to be something else other than 1 that goes here. But it does just give 1 CO2. So I'm hoping that you can figure out, if you know what this is, but you'll be able to figure out how many waters need to go here, what number needs to go on this box. This next one, they don't really tell you what the reaction is, but it's the zinc and hydrochloric acid one, and that's what it really looks like. That's zinc and that's hydrochloric acid. It dissolves in the hydrochloric acid, and you end up getting it to react, and you get all these bubbles coming off. Those bubbles, of course, are hydrogen gas. So the reaction here is what I'm showing you, and I'm asking you just to put whatever number needs to go here to balance the reaction. So it's zinc solid, and that's hydrochloric acid. We get hydrogen gas, and hydrogen gas is H2, not just H. And we get zinc chloride, which is ZnCl2. So all I'm asking you to do is figure out what goes there. For this last one, I've given you a hint as to what the reaction looks like, but I haven't told you what the solid formed is. I'm going to ask that you try and figure out what solid you're getting and what the formula of that solid is. And I want you to use the ions that you figured out up here in order to see what you're going to get for this. Now, I want you to realize that if you had this situation as AlCl3 and NaOH, and you combine them together, what would combine to form a solid would be Al3 plus and OH minus. But as you can clearly see, if we had 3 pluses and OH minus, there's no way we'd get a neutral compound. In order to get a neutral compound, what I'd need is 3 OH minuses like this, so that I could balance the charges and get the proper solid here. So the solid that I would get from this would be AlOH3. You're going to do something similar with the nickel, and then figure out what solid goes here, and then figure out how to balance out the reaction that you're given here.